Hello everybody, I hope you are good. If you are wondering how a bivariate regression model can be estimated using the robust PLSe2 estimator, this is something that I'm going to show you in this video. So this is our bivariate regression model. As you already know, we have two factors here. The first factor is job performance and the second factor is job satisfaction. If you watch my previous video, you already know that the two first items of job performance factor were not contributing items. That's why we deleted these two items from the model. Okay, now to obtain the PLSe2 results, what we are going to do is to modify the EQS file of the previous example. To be exact, we are going to change the method of estimation from maximum likelihood to PLSe2 under the specification sections. We also need to add the technical section to our EQS file, and under the technical section we have to add this statement: start is equal to PLS. Now let's go to EQS to review the EQS file for this example and modify it. Okay, let me open the EQS file for the previous example. So this is the EQS file for the final model. If you remember, we had one multivariate outlier. We deleted this multivariate outlier from our data file. Also, you can see that the method of estimation is maximum likelihood and robust maximum likelihood. You can see the number of cases and variables in our data file, the labels and the name of the variables in our data file, and also the equations and the variances. Note that there is no covariances specified here because we didn't have any covariances in our model. The tables are displayed in equation format. I'm going to change it to compact, and you can see that all of the fit indices are displayed in our output file. So let me just run this model again. And these are the results based on the maximum likelihood methodology. You can see all of these factor loadings and the R-square statistics. Let me just close this, and to obtain the PLSe2 results, what I told you was that you need to change this maximum likelihood to PLSe2, and also you have to add one section at the end of your EQS file, which is the technical section. So technical, alright, and then under the technical section you need to add a start is equal to PLS. That's all. And now let me just save this model file as model 2 PLSe2 method. Okay, and now to run this model I can simply select this option, run EQS. Okay, and now this is the results based on the PLSe2 method. Let me just scroll down to the very end. You can see the factor loadings and also the R-square statistics here for the items and also for the only dependent factor in our model. Now let me open the results report based on maximum likelihood methodology and just compare the results in terms of factor loadings and also variances, covariances, and fit indices. Okay, so this is the results based on maximum likelihood method. Let me just scroll down, close this window. Alright, now you can simply see that the factor loadings based on PLSe2 and also based on maximum likelihood are quite comparable. With respect to the pass coefficient between factor 1 and factor 2, the standardized pass coefficient, you can see that here we have 0.299, and for the maximum likelihood method, this standardized pass coefficient is 0.261. With respect to the R-square values, you can see that for job satisfaction factor as our outcome factor, 8.9% of this factor is explained by job performance based on PLSe2 method, and based on maximum likelihood, only 6.8% of job satisfaction is explained by job performance. Now let me just scroll down a little bit so that you can see the variances here. You can also compare the variances. For example, the variance of job performance here is 0.198. Based on maximum likelihood, it is 0.174. You can see that all of the variances are statistically significant, as you can see here, and the values are also comparable. With respect to the disturbance variance, you can see that here we have 0.366 based on PLSe2 method, and here for maximum likelihood it is 0.382. Let me go to the robust fit indices. Okay, now here based on PLSe2, the Satorra-Bentler scale chi-square is 2.207.12. Here it is 194.25. The degrees of freedom are exactly the same, 26 in both analyses. Also, you can see that in terms of fit indices, here CFI for based on PLSe2 is 0.957. Here it is 0.96. Also, with respect to RMSE, you can see that the RMSE value here is 0.059. Here, based on maximum likelihood method, it is 0.057. So this is how you can specify and estimate a bivariate regression model using the PLSe2 estimator. I also compared the results across the PLSe2 and maximum likelihood method to provide more insights about these two methodologies. Okay, thank you very much for watching this video.